Hello everyone, welcome to Incredible Study. Today in this lecture, we know about these all topics because this is a rapid revision lecture. Since this lecture is rapid revision, I will revise these all topics in rapid form. Okay, so without getting delay, let's start our lecture.
Welcome to Incredible Study.
Here first our topic is force. We define force. What is force? Pull or push of the object that changes the state of the object. It means state means what? Means suppose the object is in rest, then it will change into motion when we apply force. Okay, and when the object is in motion form, then it will come to rest when we apply force. There are two types of force. One is contact force and another is non-contact force. And their force may be balanced or unbalanced. Here we know force is a vector quantity. Force is a vector quantity. Its unit is Newton. And this is the SI unit of force, that is Newton. And its CGS unit is dyne. And we know 1 Newton is equal to 10 to the power 5 dyne. This is some introduction about force. Now we move to our next topic, that is gravitation. These all are our topics that we are going to discuss in this lecture. First one is gravitation. What is gravitation? The force of attraction between two bodies due to their masses. This is force of gravitation. This is called gravitation. This is the force existing between two bodies. Suppose here are two bodies, body A and body B. The force that exists between them is called gravitation. This is called gravitation, and its symbol is G. Now it is the force, so we can denote it with F. Now we move to our next topic, that is Newton's universal law of gravitation. Newton's published a law related to gravitation, and he tells in his law, that is every body in the universe attract every other body with the force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their center. It means, suppose this is a body having mass m1 and m2. Let it is the center of a body, this body. Then let this be distance, this from here to here. This is distance. According to his law, what he tells, F is equal to F is directly proportional to, force is directly proportional to the product of masses of the body, and even force is inversely proportional to the square of the distance between their two bodies, distance between two bodies from their center. It means d square. When we combine this force, then we will get value, means that is formula. Here F is equal to put equal to, we need to put here constant first, so here G is constant. And now we from this first equation and second equation, we write here m1 m2 by d square. This is the gravitational force existing between body A and body B. He tells this in his law. His law states this, Newton's universal law. Everybody in the universe attract every other body with the force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Now we go to our next topic, that is universal gravitational constant. Universal gravitational constant. Here G is universal gravitational constant. It means what? When suppose here m1 is equal to, let m1 is equal to 1, m2 is equal to 1, and distance between these two bodies is equal to 1 unit. These all are in unit. It has some unit, that is kg, kg and meter. Now we write formula here, G m1 m2 by d square. Here F is equal to G, here 1 into 1 by 1 square. We get F is equal to G. So we can define, this is the force existing between two bodies of unit masses which are separated by unit distance. This is called universal gravitational constant, and its unit is Newton meter square per kg square. We can derive its unit from this formula. In previous lecture I had already been discussed this about this one. So we can write here G is equal to, by cross product, F into d square by m1 m2. Now we write unit for each quantity, that is for force we write Newton, for distance we write meter square, and for two masses we write kg square. So we can write here G is equal to, unit of G is equal to Newton meter square per kg square. Here I am using this. This is the SI unit. This is SI unit. Okay, and its value is found to be 6.67 into 10 to the power minus 11 Newton meter square per kg square. Per kg square, here minus means per kg square. This is the value of capital G, universal gravitational constant, in SI system. Okay, and in dyne I had already been discussed in previous lectures, so you can even see from previous lectures. Now we go to our next topic, that is change in gravitational force due to masses and distance between them. What will be the change in gravitational force when mass of the one body is halved, doubled, okay, and when the distance between them is halved or doubled? When variation in mass or distance takes place, then what will be the effect of such variation on gravitational force? Now we find here gravitational force, change in gravitational force due to masses. Here we have formula F is equal to capital G m1 m2 by d square. There are, for masses we take two cases, when mass of one object is doubled, and in another case, that is mass of two objects is doubled. Suppose these are object having mass m1 m2 and distance between them is, remember distance is always taken from center. Okay, so we have formula this for these bodies, for these two bodies, F is equal to capital G m1 m2 by d square. Now we are going to see what will be the change in gravitational force. Case 1, this is for masses. This is for mass, when variation in mass takes place. When mass of one body is doubled, then what will be? Then here in this case, what will be? m1, suppose the body mass of body A is doubled, then here m1 is replaced by 2m1, because the mass is doubled. So we can write 2m1 here. So we can write here G, instead of m1 we can write here 2m1 m2 by d square. That is F is equal to 2 times of G m1 m2 by d square. Now F is equal to 2, let this be this force changing, this is the force after changing mass. So we can write here this, its value is, you can see here force, its value is F. So we can write here, as a conclusion we get, when mass of one body is doubled, the force is gravitational force between such two bodies is also doubled. When mass is doubled, the force between them is also doubled. Now we see case second. In case second, what happens? Mass of both bodies are doubled. Masses of both bodies are doubled. Then what will be changed? Here we can replace m1 by 2m1, and even we can replace, here m2 by 2m2. Since masses of these two bodies is doubled, masses of two bodies are doubled, then we can replace m1 by 2m1 and m2 by 2m2. So we can write here F is equal to G 2m1. Instead of m1 we write 2m1, and instead of m2 we write 2m2 by d square. Here distance is constant, only variation is mass taking place. Okay, so we can write F is equal to 2 into 2 4, and G 4 times m1 m2 by d square. This is force after changing mass. F is equal to 4 times of, this is its value is F. So we can say, when masses of the two bodies are doubled, then its force will be, its force means what? Gravitational force between them will be 4 times of the previous gravitational force. We have discussed cases related to mass. Now we discuss what will be the change in gravitational force when distance is changed, when variation in distance takes place. Here we write for distance. For distance means what? Variation in distance. Case 1. In case 1 we discussed when distance is halved. When distance is halved, it means d by 2. Here d is, then we get d is replaced by d by 2. We can write here F is equal to capital G. This we have this. Now we can write instead, here masses are constant. M1 m2 by, instead of d we can write d by 2 whole square. So F is equal to G m1 m2 by d square, and this 2 square will be here. Okay, so we can get F is equal to 4 times of capital G m1 m2 by d square. F, this is the force after change in distance. F is equal to 4 times of this force. What we can see here, when the distance between two objects is halved, then its force, means the gravitational force existing between them is increased by 4 times. Now similarly we go to case 2. Case 2. In second case we can see here when distance is doubled. When distance is doubled, it means d is replaced by 2D. D is replaced by 2D. What will be here? Force after variation in distance. Here capital G, M1, M2 masses are constant. So instead of D, we write here 2D. 2D whole square. It means F is equal to 1 by 4 and G M1 M2 by D square. Square of this, square of 2 will be 4 and square of D will be D square. It means F force after variation in distance is 1 by 4. This is F. What can we conclude here? We can conclude when the distance between two bodies is doubled, then force, gravitational force between them decrease by 4 times. Here decrease by 4 times. Okay. Similarly, we move to our next topic. That is gravity and gravitation. Differences between gravity and gravitation. Here gravity. Before going to differentiate between them, we need to know about gravity. What is gravity? Gravity is the force of a force with which heavenly bodies attract any object towards their center. We can see here Earth. This is Earth, suppose, and this is Earth. When bodies are kept here, then this attract towards center. Always center. It attracts force always towards center. So we can say this is the force with which heavenly bodies attract any other bodies towards its center. Okay. Now we go to write difference between these two terms, gravity and gravitation. Gravity and gravitation. Gravitation. We write difference here. First difference we write, it is the force with which heavenly body attract other bodies towards its center. Force with which heavenly bodies attract other bodies towards their center. Towards their center. This is gravity. Now it is, what is gravitation? This is the force of attraction between two bodies. This is the force of attraction. Attraction between, this is between two bodies due to their masses. Due to their masses. This is the gravitation. Okay. Here in next point we write, what we write, gravity is, it is the force, it depends upon only single body. It depends upon only single body. You can write fairly, it depends upon only single body, and this depends upon two bodies. Two bodies. Okay, this depends upon two bodies and this depends upon single body. And now we similarly go to our next topic, that is acceleration due to gravity. What is acceleration due to gravity? Now we go to our next topic, that is acceleration due to gravity. When we apply force on any moving bodies, then the velocity of such bodies changes, and this change in velocity is called acceleration. This change in velocity is called acceleration. Similarly, when we lift any object, then it falls down. It falls down due to the force that is gravity. Okay, gravity means what? It is the force of the attraction. Gravity is the force of the body, heavenly bodies, with which they attract any other bodies towards center. I am leaving this lead of marker and it falls down. It means force is attracting this body. This means its velocity also changes, and this change in velocity is called acceleration. So acceleration produced on this body due to gravity. Here acceleration is produced on a body due to force that is gravity. Due to gravity. So this acceleration is known as acceleration due to gravity. It means this acceleration is produced on a body due to gravity. Here gravity is a force. Gravity is a force. So acceleration is produced on a body due to gravity. And acceleration due to gravity, the symbol of acceleration due to gravity is g. Small g. Small g. This is the vector quantity. This is a vector quantity. How we can determine this is a vector quantity? Object only falls towards center. Therefore, this is vector quantity. Okay, and its value changes from place to place. Its value changes from place to place. Now we discuss our next topic, that is difference between small g and capital G. Here small g is acceleration due to gravity and capital G is universal gravitational constant. We discuss here small g and capital G. This is the rate of change in velocity. Rate of change in velocity means acceleration. Rate of change in velocity due to gravity. Rate of change in velocity due to gravity is called acceleration due to gravity. Acceleration due to gravity. Now, what is universal gravitational constant? I have told you this under this topic, that is universal gravitational constant is the force existing between the bodies of unit masses separated by unit distance. So we can write here, this is the force existing between bodies of unit masses separated by unit distance. Is called universal gravitational constant. It's called universal gravitational constant. And in next point we discuss acceleration due to gravity is a vector quantity. It is a vector quantity. And here universal gravitational constant is a scalar quantity. It means its value does not get changed. That is, we write it is a scalar quantity. And in third point we can write its value. What is the value? The value of acceleration due to gravity of Earth is 9.8 meter per second square. 9.8 meter per second square. So we write here value is equal to, here value is equal to 9.8 meter per second square, and its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, and in next point we can write its unit, that is the unit of acceleration due to gravity is meter per second square, and unit of universal gravitational constant is Newton meter square per kg square. These all are the differences between small g and capital G, that is acceleration due to gravity and universal gravitational constant. Now we discuss our next topic, that is variation in G. What will be the change in acceleration due to gravity and where? Variation in G. Variation in G, acceleration due to gravity. Here acceleration due to gravity, since the structure of earth is like this, it means orange shape. On the earth surface the value of G get changed. First one, earth surface. On the earth surface the value of acceleration due to gravity changed. This is equatorial part, and this is polar part, pole. This is pole and this is equator. Here the distance is greater. Before this I want to show you the formula of G, acceleration due to gravity. This is capital G, small g is equal to capital G m by r square. This is the formula of G. Okay, acceleration due to gravity. Here G depends upon mass. This is mass of a heavenly body. Heavenly bodies means Earth, Mars, Jupiter, like that. And it also depends upon radius of heavenly bodies. Radius of heavenly bodies means we know about this. So here this is directly proportional to the mass and inversely proportional to radius. Here radius is, when radius is more, the value of acceleration due to gravity will be less. When radius is greater, the value will be small, means less. Here on equator, in the equator we can see the radius of earth is greater. Radius of earth on the equator is greater, and this is radius of the earth on pole. Since radius of earth in equator is greater than radius of earth at pole, the value of G will be changed, just opposite. The value of acceleration due to gravity on the equator is less than the value of acceleration due to gravity on pole. It means the value of G will be maximum on pole and will be minimum on equator. Will be minimum at equator, that is the maximum value of small g, that is acceleration due to gravity of the earth, is 9.83 meter per second square, and this is at pole. Here minimum value is 9.78 meter per second square. This is minimum value of earth of acceleration due to gravity on earth at equator. This is maximum and this is minimum. So we can see first case, on the earth surface the value of acceleration due to gravity get changed. Next case we see with height. Formula will be, here when height is added here, let this be r now. Let this be r. When body is kept here, at height h above from the earth's surface. Then in that case the formula of g will be, this is g when height is increased, g will be capital G capital M by r plus h whole square. This will be the formula when body is at certain height h from the earth's surface. When height increases, the value of acceleration due to gravity decreases. So in this case we can write g when height increases, the value of g get decreased. In this case with height, acceleration due to gravity decreases with increase in height. And in third case we discuss with depth. Okay, when we go below from the earth's surface, what will be change in gravity? What will be change in acceleration due to gravity? So when we go down, then we only take a radius up to this much. When we go from here to here, then we take a radius up to this much, and then after we take only mass of this one, it means acceleration due to gravity get decreased when mass get decreased. When mass get decreased, acceleration due to gravity also get decreased. So we can write here with depth, when depth increases means when we go below the earth's surface, the acceleration due to gravity get decreased. One thing you remember, you may be asked one question, that is what are the places where value of acceleration due to gravity is 0? Then what you will tell? You have to tell what is in 3 cases the value of acceleration due to gravity get 0. First case, when the body is in weightlessness, the value will be 0. The value of acceleration will be 0. First case. Case number 1, in weightlessness. Second case, at center of the earth or center of the heavenly body. At center, the value of acceleration due to gravity is 0. And third case is null point. It means in space. Null point means somewhere in space. Null point. You need to know about these. In these all conditions, the value of acceleration due to gravity is 0. Okay. Therefore, we write here g is equal to 0 in these cases. We move to now our next topic, that is mass and weight. Under this topic, we only discuss differences between mass and weight. What will be the difference between mass and weight? Here, first one, we can say what is mass. It is total amount of matter contained in a body. It means number of atoms or molecules present in a body. Suppose mass of this marker is 10 gram, then sum of these atoms in this marker is 10 gram. So we can write total amount of matter contained in a body. Total amount of matter contained in a body. is called mass of that body. Weight. What is weight? This is the force on a body exerted due to gravity. Force on a body exerted due to gravity. We can write force exerted on a body due to gravity. Force exerted on a body due to gravity is called weight. In next point we write what is the unit of mass. The unit of mass in SI system is kg, that is kilogram. Unit in SI is kg, and unit of weight, since this weight is force, its unit is Newton. Unit in SI is Newton. This is symbol of Newton. And in third point we write here mass is constant. It is a constant quantity. It means mass does not get changed with place to place. Suppose mass of this marker is 10 gram. Then when we take this marker to the moon, then its mass remains constant, that is 10 gram. So we can write it is a constant quantity. And the value of W, that is, it is denoted by W. The value of weight get changed place to place. Here it is so we can write here weight is a variable quantity. Mass is a constant quantity and weight is a variable quantity. Now we write here under same point we write here W is equal to mg. It means weight of a body depends on acceleration due to gravity and mass of that body. Acceleration due to gravity of a heavenly body and mass of such body. That is, when acceleration due to gravity changes, the value of W also get changed. So we can write this is a variable quantity. Similarly, we have finished our 9 number topic, that is mass and weight. Now we move to our next topic, that is free fall and weightlessness. This is last topic for this lecture. Now we discuss our next topic, that is free fall and weightlessness. What is free fall and weightlessness? Free fall means when a body is falling only under the influence of gravity, then the body is said to be in free fall. When we can write here free fall, when a body is falling only under the influence of gravity, then body is said to be in free fall. When a body is falling only under the influence of gravity, then body is said to be in free fall. Once Galileo Galilei said bodies in the free fall is dependent, means the acceleration due to gravity on the body in a free fall is independent of its mass. So here there was one physicist who did not agree with his statement. So he and the physicist named is Robert Boyle. The name of physicist was Robert Boyle. He did not accepted the statement of Galileo Galilei. So to prove the statement, he performed one experiment known as Robert Boyle's experiment, or popularly known as coins and feather experiment. In previous lecture, I have also discussed about this topic, Robert Boyle's experiment or coin and feather experiment. What happened? In that experiment, two jars are taken. This is jar, two jar, and since two bodies are taken to perform this experiment, that is coin and feather. So this experiment is known as coin and feather experiment. What happened in first case? He put coin and feather. This is, suppose this is feather. He put coin and feather at some height and he dropped these two bodies. Then what happened? Coin falls faster and feather slowly. Feather fell slowly. Then in next case, what he does? He ejected all the airs in the jar. It means the jar, inside jar there is vacuum. Jar is vacuum. So in that condition, he performed same experiment. This is feather. He put coin and feather at some height in the jar, and he left and he dropped these two objects at the same time. Then he found astonishing result. What he found? He found the same, both object falls at the same time. Both objects hit the ground at the same time. It means what he found? He found the statement of Galileo Galilei to be true. Okay. Therefore, he gave one conclusion that acceleration due to gravity of a free falling body is independent of mass and is same for all bodies. It means acceleration produced on coin is same for this feather also, and this is independent, and acceleration due to gravity in free fall is independent of their masses. This is experiment done by Robert Boyle. Now we discuss weightlessness. This is next topic, weightlessness. What is weightlessness? What is weightlessness? Weightlessness means when we fall from any height. Suppose someone push you from ceiling, then what do you get? You feel loss in your weight, and this loss in your weight is called weightlessness. It means when we travel from, or when we fall from somewhere, then we feel loss in our weight. And this loss in our weight is called weightlessness. So we can write in this case, when the weight of a body is zero, feels zero, then it is called weightlessness. What is weightlessness? When the weight of the body is filled zero, then that is weightlessness. Okay, that is weightlessness. It means weight of a body in this case is 0. And why the weight of the body becomes 0? Because there is g is 0. G is equal to here 0. So therefore when g is equal to 0, so W will be 0, and this condition is said to be weightlessness. So therefore our lecture ends here, and in this lecture we have discussed these 10 topics. This is the rapid revision lecture. So I have discussed these all topics in fast form. Okay, so if you like this lecture, then like our video and subscribe to our channel. Thank you for today.